Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are going to talk about quasi-experimentation. This topic is based on a tech blog with the title Optimizing at the Edge, using regression discontinuity design to power decision-making, written by the economics team at Instacart. You can find the blog link in this episode's description. Throughout this episode, we will dissect the topic from both business and data science angles. Now, let's dive in. On the business side, let's take a look at the problem to be solved. Instacart is a leading online grocery delivery service that connects customers with personal shoppers to deliver groceries from local stores. Founded in 2012, Instacart partners with various retailers, allowing customers to shop from their favorite stores through the Instacart app or website. As a technology company, Instacart uses experimentation methods to evaluate the impacts of product changes and make informed decisions. While A/B testing is considered the gold standard for running randomized experimentation to test hypotheses, quasi-experimentation offers a strong alternative for assessing product opportunities by observing behaviors without the need for online randomization. Quasi-experimentation is a research method that compares outcomes between groups that are not randomly assigned. It uses naturally occurring groups, or those selected based on specific criteria. Unlike standard A/B testing, where participants are randomly assigned to groups to compare different versions of a variable, quasi-experimentation relies on statistical controls to account for differences between non-randomized groups. Quasi-experimentation is particularly valuable when random assignment is impractical, unethical, or impossible, such as in a study of policies, large-scale educational programs, or historical events. For instance, consider a situation where Instacart may want to evaluate the impact of a new loyalty program designed to increase customer retention. Implementing a randomized control trial for this program would be challenging because it would involve randomly assigning some customers to receive loyalty benefits while others do not, which could disrupt their experience and potentially lead to dissatisfaction. Instead, Instacart might use quasi-experimentation to assess the program's impact by comparing outcomes between customers who join the loyalty program at different times. By analyzing naturally occurring variations in the timing of the program's rollout, Instacart can infer the effects of the loyalty program on metrics such as repeat purchase rates, average order values, and customer satisfaction. This approach allows the company to gather insights on the program's effectiveness without the need for random assignment. This could minimize the disruption on customer experience while still make data-driven decisions to enhance the service and drive their growth. Now that we've understood the business needs for quasi-experimentation, let's dive into the technical side to explore a classic quasi-experimentation method for answering business problems: regression discontinuity design. Regression discontinuity design is a quasi-experimentation method used to evaluate causal effects by exploiting a cutoff or threshold in an assigned variable. In regression discontinuity design, units just below and just above the cutoff are assumed to be similar in most respects, except for the treatment they receive. This assumption allows researchers to estimate the causal effect of the treatment. Consider the example of Instacart, where customers who can place orders before noontime, they receive a 2-day delivery window, while those who order right after the noontime will receive a 3-day delivery window. By saying delivery window, meaning that when they would expect their goods to be delivered, in either next 2 days or 3 days. In this case, the cutoff is the exact time of noon, or 12 p.m. Customers arriving just before and just after this time are likely to be similar in many ways, except for the delivery window they are offered. The similarity allows researchers to use this regression discontinuity design to infer the causal effect of changing the delivery window. In regression discontinuity design, there are two key concepts involved. One is called local average treatment effect, and the other is called average treatment effect. The local average treatment effect refers to the average causal effect of the treatment for individuals who are just at the margin of receiving the treatment, meaning those near the cutoff point. It is local because it applies only to units very close to the threshold. In the Instacart example, the local average treatment effect represents the effect of changing from a 2-day delivery window to a 3-day delivery window for customers who place their orders just before or just after noon. On the other hand, the average treatment effect represents the average causal effects of the treatment on the entire population, not just those near the cutoff. In the Instacart example, the average treatment effect reflects the overall impact of changing from a 2-day delivery window to a 3-day delivery window on all customers. This includes both those close to the 12 p.m. time, where the local average treatment effect is measured. It also covers those further away from this cutoff time. The average treatment effect provides a broader understanding of how the change in the delivery window affects the entire customer base, not just those who placed order around noontime. Regression discontinuity offers a clear view of the local average treatment effects and can be used to estimate the average treatment effect of the product change. The actual average treatment effect would eventually need to be measured through A/B testing. Now we understand what is the regression discontinuity design. This framework can be leveraged as the powerful tool for evaluating product trade-offs by examining how different decisions impact key metrics around a specific threshold. Considering the previous example, if Instacart is considering moving the threshold from 12 p.m. to 1 p.m., then those customers placing orders between 12 to 1 a.m. would likely to have more orders placed. On the other side, these new orders would also add pressures to the delivery system to meet the new deadlines. Now we understand how the regression discontinuity method works and can be used to make trade-off decisions. The team further applied it to a specific use case. discontinuous authorization buffers at the company. This addresses one very interesting business need. Let's take a look at this part. When customers shop on Instacart and click on the Place Order button, the team knows the initial cost of this item in the customer's cart. However, customers can still make changes or add items after placing this order, and this might change the actual charges to their credit card. To account for this potential change on the order, the team places an authorization hold based on the initial cart total value plus an additional buffer amount. So now there are trade-offs involved with this buffer amount. With a higher authorization hold buffer, it reduces the risk of the potential unpaid amount. But this also creates a confusing customer experience. So now the question is, how to make the right policy to choose the buffer authorization? To determine the optimal authorization buffer, the team looked at a natural experiment within the existing buffer policy. The existing policy works as follows. First, a buffer of 10% is added to the order's total amount. Then, the resulting total is rounded up to the next $5 increment to avoid odd-looking authorizations. This second step creates a discontinuous effect. Every time the first step results in an amount that just exceeds a multiply of 5, the total authorization amount jumps by $5. As a result, two orders can generate a $5 difference in the authorization hold, even if their actual order amounts are only just 1 cent difference. With this understanding, the team analyzed the discontinuous behavior using regress discontinuity to understand how this $5 hold difference impacts the various metrics, such as credit card decline rates. With this understanding, they propose new policies and deploy A/B testing to measure the overall impact on the customer's experience. Now we discussed both the business problem and technical solution. Let's wrap it up. In this episode, we explored the concept of quasi-experimentation and its role in Instacart's decision-making process. We took a closer look at one specific methodology, regression discontinuity design, explaining its key concepts and demonstrating how it works through an interesting example. If you like the content of this episode, please subscribe to the channel. Give me a 5-star review and leave a comment. Your feedback is very appreciated, and I'll see you next week.